Alright, so we have three examples here of functions a, b, and c of x, and we're asked to find, let's write that, find HA. Class, what does HA stand for? Horizontal asymptotes. Okay. Let's compare the top versus the bottom. Put your finger on the numerator and point to its degree. Show your partner, give a head nod. There is the numerator, there's its degree. The number is 2. Put your finger on the denominator, put your finger on the degree. The degree is a 1. 1. Don't use that pen, it smears. 1. Ripped a hole again. Sorry. Okay, what inequality can you put in there? Okay, inequality lesson. The distance between this line and this line is small. The distance between this one and this one is big. This is bigger than this number. Larger. 2 is greater than 1. Look at your chart. Where is it greater than? And our answer is what? None. Horizontal asymptote, there is none, is my answer. If you graphed it, which I'm just going to give you a quick sketch, it looks something like this. I know you might be saying like, okay, looks something like this, right? But it's kind of slanted. Do you see that? That's why it's not a horizontal. Okay? So all you have to do is not be worried about what's in front of it, where it is. You just look for the highest degree in the numerator and denominator. Let's try number 2 together. Put your finger on the top degree. What number is it, class? So I'm not worried about the 1, the -6, doesn't matter. We're just looking at the 1. Put your finger on the bottom degree. What is it? I highlighted nothing there. The number there is 1. Partner A tell partner B what inequality you're going to put there. And then partner B tell partner A what do we know about the horizontal asymptote. Jaime, what inequality sign goes there? Jaime? Jaime, what inequality sign goes there? 1. So your choices are greater than, less than, or equals to? Equals to. And if I look at my chart, Cameron, what does it tell us? Okay. Reduce. What does it mean to reduce? I'm going to take the highest degree and all of it with it. So let me use my red pen. So this becomes -6x. Okay? And then this is your highest degree in the denominator. So I'm going to take all of it. This is 3x. And we basically just need to reduce this. So I see -2 times 3 times x. I see 3 times x. What can you cancel or reduce, class? The 3's and the x's. And you're left with a -2. So our horizontal asymptote is y equals -2 is our answer. When you take the degrees, the highest degrees, and the top is equal to the bottom, you have to reduce. And when we reduce, we're left with -2, and you're going to put a y here. You might be asking the question, why? Well, if you graph y equals -2, say you don't know how to graph that by hand, you just make a table of values. And it tells you all the y values are what? What is it? -2. So you just, all the y values are going to be -2. Everyone say make up. You make up numbers. Don't put it on. And then if we graph those, 0, -2, 1, -2, 2, -2, it is a, what type of a line? Horizontal asymptote. Notice how when we did verticals, the equation was what? X is not equal to. Does that make sense? And then the graph looks something like this.
So the x is not equal to, but the y is equal to?
Yes. It just tells us this one is the equation of the line. They're essentially equations of the line. And let's do example number 3. Partner beats up partner A. What are the two numbers you're going to write there in the inequality? And the other person tell us what happens. Let's take 30 seconds. Ready, set, go. She's right. It doesn't matter.
So
5 seconds. Calling on you. Make sure you and your partner know what to say. Pablo, what is the top degree? 2. Raise your hand if you got 2. Good job. Bottom degree. Brianna. Echo? 3 is correct. Brianna, what inequality do you write there? You are correct. If I write less than, Ruben, what do we know about the horizontal asymptote? The answer is y equals 0. Raise your hand if you got that. Let's put it in a red box. Quick visual. That means it's actually on the y-axis itself. I'm sorry, the x-axis itself. And the graph might look something like this. Okay? So all you have to do in horizontal asymptotes, do you have to factor class? No, all you have to do is look at the degrees and compare them, and it tells us what kind of horizontal asymptote we're going to have.